So we have this function, f of x, the green function, and we've got a point A, that's our x-coordinate, and f of A is our y-coordinate, and we put in some numbers in blue, just 5 and 12, okay? We want to represent this idea over here. Remember in the analogy we talked about approaching a point on the riverbank from the left. And the way we represent that is with the idea of a limit. What is the limit as x approaches 5? And I'm going to put a little negative sign as a superscript on the 5. That negative sign up here means from the left. When we decide to approach from the right, instead of a negative sign, we're going to put a plus sign. So this says, what is the limit as x approaches 5 from the left of f of x? So it says, take the function f of x, take the green line, and what value does the function approach as you come in from the left? So as a gets closer and closer to 5, as a gets closer and closer to 5, what value does y approach? Our y-coordinate gets closer and closer to 12. So we would say the limit as x approaches 5 from the left of f of x is equal to 12. What about the limit as x approaches 5 from the right of f of x? So now we're talking about coming in from the right. So as you approach a, as you approach 5, coming in from the right, what value does the function approach? So when you come in from the left and when you come in from the right, they approach the same number. So that's good. That's part of our bridge analogy, right? The roads meet. The roads meet at the same place. All right, cool. So that's condition number 1. And we'll write it this way. Mathematically, what we're saying is the limit as x approaches a from the left equals the limit as x approaches a from the right. This is condition number 1. In addition to our roads meeting at the same spot, we need this bridge to be in the same place as the roads. Well, this bridge is really f of a. It's the actual value. So when we're talking about limits, it's like we're approaching it, but we're never getting there, sort of like an asymptote. What is f of a? Not what's the limit as it approaches, but right at the point 5, what is the value of y? And we know that f of 5 is equal to 12. We set that up here. So this is condition number 2. So over here we'll say condition number 2 is that f of a equals the limit as x approaches a. Number 1, the roads have to meet at the same spot on the bank. And number 2, there has to be a bridge. Take a look at this guy. So here's a function, a red function. We'll call it f of x. And let's ask some questions about f of x. For example, what is the limit as x approaches -4 from the left? So as we get closer and closer and closer, it looks like it's approaching the point, or the y value 3. Yep. So we'll say this is equal to 3. What is the limit as x approaches -4 from the right of f of x? So now, as you're traveling along this function, coming in from the right, what value does the function approximate? What does it approach? -2. So on this little window at -4, is the function continuous? No, it's not continuous. How come it's not continuous? Well, because the limit as you approach from the left is different than the limit you approach from the right. So we would say that the limit as x approaches -4 does not exist. The limit doesn't exist because when you come in from the left and you come in from the right, they approach different numbers. And so the limit doesn't exist overall at that point. So basically, rule number 1 is violated. Our roads don't meet up on the riverbanks. One's above, one's below. One more question. What is the value of f of -4? Yeah, it's equal to +3, right? Because you've got a closed dot here and you've got an open dot here. And remember, this idea of a limit isn't what is the value at that point, it's what does it look like that value's approaching. And so from the left, it looks like we're approaching positive 3. From the right, it looks like we're approaching negative 2. Those numbers are different, and so the limit doesn't exist. If we say the limit as x approaches 4 from the left, we want to know what that is. And then we want to know what the limit as x approaches 4 from the right is going to be. Okay, so coming in from the left, coming in this way, what is the y value that the graph approaches? Looks like it approaches 2. And now come in from the right side. So coming in from the right, this way, what y value does the graph approach? 2. So far so good. Our roads line up on the riverbanks. They're right across from each other. Now all we need is a bridge in the middle. So the bridge in the middle is, what is f at 4? What is f of 4? What is the value of the function right at that point? And the answer is? Yeah, it does not exist. Undefined. There is no point at 4 because there's a hole in the graph. So is this function continuous? No, it's missing the bridge. Right? The bridge is gone. Now, if we were to go in and actually fill in this dot, now you would have a continuous function. Now you've got both roads coming in, they meet, and there's a bridge at that point. What is the limit as x approaches 2 from the left? So coming in on this graph from the left, what value do you approach? What y value do you approach as x gets closer to 2? Yeah, negative 3. And now come in from the right. So what y value do you approach as x gets closer to positive 2 from the right? Negative 3. And so what is the limit? And notice on this guy, there's no positive or negative here. Now in this case, these are the same values, so the answer is negative 3. However, if this one came into negative 3 and this one came in at negative 4, you would write D and E. You would say that the limit doesn't exist because the left is different than the right. In order for the limit to exist, it has to approach the same number, both sides. And then finally, what is f of 2? If you actually plug in 2, what would you get? Positive 3. Yeah, that's this point up here, 2 comma 3. Considering this graph, check the statements that you agree with. Is f of 2 defined? Yeah, f of 2 is defined. By the way, f of 2 is equal to what? Yeah, negative 2. Yep. Does the limit as x approach 2 exist? So the limit does not exist because the coming in from the left is different as you're coming in from the right. All right, next question. The limit as x approaches 2 of f of x is equal to 2, or is equal to f of 2. Is that a true statement? No, because this limit doesn't exist, first of all. It doesn't exist. What would you change on this one to make it true? Yeah, if you said the limit as x comes in from the left, is the limit as x comes in from the left equal to f of 2? Yes, it is. I would check that. But if you take that negative sign off, if you don't specify what side it's coming in from, one goes to negative 2, the other one goes to negative 3. So we can't say that they're the same. The function is continuous at x equals 2. Nope, not continuous. The function is not, I think I just said that, check. So we check the last one. This function is not continuous. The roads don't line up. What if I don't give you a graph? So you think that all I got to do is take that negative 1 and plug it in? All right, so we're going to say 8 times negative 1 squared. So you think the limit as z approaches negative 1 of that function, 8z squared minus 5z, is just 13. So if we zoom in on this guy, here's a negative 1 right here. So if we follow this line up, right about there, how's that? So you're right. Okay, so here's a function. It looks kind of like an exponential. And let's say that we wanted to find the slope at some point called x. So what is the slope of this function at that point? And so you would, draw a tangent line, and we'd have to find out the equation of that tangent line. Well, how are we going to know the equation of that tangent line? Like, we kind of sketched it, right? And what if my sketch is bad? What if I don't draw it exactly tangent? It's a little bit off. I'm finding slope. And so here's an idea. We talked about how you needed 2 points to find slope, right? So let's pick another point. Let's pick a point out here. And let's draw it right there. And what we could do is, if we took these 2 points and we calculated the slope between these 2 points, that would give us an approximation for the slope, right? It's not going to be exact, but it's probably pretty close. So if this point is x, let's label this distance something. Let's call this distance h. So h is going to be the distance between these 2 points. So what's the label of our second point? This is x plus h. So the x-coordinate of our first point is x, and the x-coordinate of our second point is h. Okay, cool. So if we take this x up and then we project it over to the y-axis, what is the y-coordinate? Just say f of x, right? And if we project this point up and over, what is this value? So our first point is going to have coordinates x, comma, f of x. That's going to be the x-coordinate and the y-coordinate. And the second point is going to have x plus h, comma, f of x plus h. So again, this is going to be your x-coordinate, and this is going to be your y-coordinate. How would we find the slope between those two? You guys said that slope was equal to rise over run. So here's your rise, that distance, and here's your run. So if we plug in our values, our rise is going to be the change in the y-coordinates. Y-coordinate, y-coordinate. So if we take this down here, that's going to be f of x plus h minus f of x. What's the change in your x-coordinates? X plus h minus x. And x plus h minus x, the x minus x, they're going to cancel each other out. So we're just going to end up with an h here. So here's the big idea. And this is huge. This idea changed the world. So this is your definition of slope. What if we took h, this green distance, or the yellow distance in between them, and what if we cut h in half and made it the slope between these 2 points? Would that be a better approximation? What if we cut it that distance in half? Would that be a better approximation? What if we cut it in half again, and half again, and half again? What would give us the exact value at that point? What would we need to squeeze h all the way down to? 0. How can we squeeze h down to 0? We can do it this way. The limit as h approaches 0. So this is 2x plus 3. We know what these answers, what is the slope of this function? 2. You know the slope's going to be 2, okay? So this is a linear function. So is the slope 2 everywhere? Yeah. What's f of a? You'll notice this f of a is this part here. And this part, a plus h, is this part here. So what they're asking you to do is find the first component, and then find the second component, and then put them together in the last answer, okay? So how would you find f of a plus h? 2 times a plus h plus 3, which is 2a plus 2h plus 3. And now put the whole thing together. So what do you notice? 2a minus 2a. Gone. Positive 3 minus positive 3. Gone. what are you left with on top? And if we were to take the limit at this stage of the game, if we were to take your 0 and plug it in, and let's just for kicks, the limit as h approaches 0. If we were to plug in that 0 right now, what would happen? Bad things, undefined, right? So we can't take the limit at this stage of the game, but what's our next move? Cancel the h's. And now what happens when we take the limit as h goes to 0? There's no h to plug it into. So what's our answer? 2. What's the slope everywhere? 2. So here's a function, 4 plus 6x squared. This is a quadratic. You know that it opens up. You know it has a y-intercept of 4. We could graph it if we wanted to, but we're not going to. What's f of a? What's f of a plus h? And now let's take all of these pieces and plug them in. Again, remember, this is f of a. That's this part here. This is f of a plus h, which is this part here. So, we got the training wheels on, right? We're taking you through step by step by step how to do this. So let's put everything together. Yeah, knock them out. What do you see? 4s are out. 6a squareds are out. 12ah plus all divided by h. If we were to take the limit right now, if we were to plug in a 0 right now, we're going to end up in that box where we've got a 0 in the denominator. So wouldn't it be nice if that h on the bottom would cancel with an h on the top? That'd make things really nice. So let's factor an h out of everything in the top. And what's going to happen with those h's? They're going to cancel all the time, every time. And this will leave you with the limit as h approaches 0 of 12a plus 6h. What happens to this function when you do take the limit as h approaches 0? What do you get? 12a. When you take this limit, that 6h goes away. The limit as h approaches 0 plugged into this function knocks out the 6h. H goes to 0, so 6 is gone and you're left with 12a.